if I make this cross? What will I get from that? This is not like the others. I don't have an F1 and F2. I just want to make that cross. What if I make that cross only?
You would also get an O blood type.
What will I get?
You would get an
Make the cross.
B, A, B.
What do you get? What will I get?
All four.
I get IA, IB. I would get an IA, little I, IB, little I. And then I would get 1, 2, 3. And the fourth would be little I, little I. So this would be type AB. This would be type A. This would be type B. And this would be type O. In this relationship, AB is codominant. That's different from partial expression. Because here I got something not green and not white. That's called incomplete dominance. This one I get type A and type B in the same person. Because each allele are equally expressed. That's what we call codominance. So codominance means equal expression. Incomplete dominance means partial expression. But all of these are monohybrid crosses. So here is a general rule for working these problems. A general rule. If you have a parent, an F1, and an F2, that's what they're asking you for. If you have a parent, an F1, and an F2, the parents are always homozygous.
The parents are always homozygous?
They are always
If they're what?
homozygous. If you have a problem where you're given the parent, the F1, and the F2, the parents are always homozygous. Okay? That's like this one I did, and this one I did it. This one I didn't do an F1 or F2. Here the parent is heterozygous, but I didn't get it go all the way through F1, F2. I want to tell you why that's the rule. Because notice when you cross a homozygous parent with a homozygous parent, you get one F1. You follow?
Yep.
How many types of F1s do I have here? All of them are what?
Color,
Big R,
same
little
color.
R. You can have 100 of them, they're all going to be the same. If one parent is heterozygous, you get too many answers. So on these standardized tests, and these tests Dr. Wong I give you, the parents are always going to be homozygous. Because there's only one answer. If you make the parent heterozygous, right away you got two answers.
Even if you had a big R, big R, big R, little r?
That's not homozygous. Look what you
know,
get.
I know.
This is what you get for an F1. Both of those you get for an F1.
Half and half.
But they still all be one color, wouldn't
And
they?
now, no, they'll be the same. I didn't say that. Everything here is all red. But the genotype is all big R, little r. So here, what happens when you cross this with each other, and that with that? That's brothers and sisters. You follow? You understand? You're not going to get a 1 to 2 to 1 when you cross two F1s. So when I say cross brothers and sisters, in this scenario that you gave me, a big R, cross to little r, I get one answer for the F1, and I get one distinct answer for the F2. 1 to 2 to 1 or 3 to 1. If I do this, I will not get a 1 to 2 to 1, and I will not get 3 to 1. It can't happen. Because when I cross this, and I get big R, little r, and big R, I got to cross this with this cell, then I got to cross this with this cell, then I got to cross this with this. Look how many answers I'm going to get. And I got to figure out, that's the real reason I got to grade this. When I can look at it, you either know it's 3 to 1 or 1 to 1 by the design of the experiment. So to make sure that you understand this, the answers are always, parents are always homozygous. Okay? Nobody's going to give you a problem like this and say, what's your F2? No, they won't. Because you can almost write whatever you want. Right. They got to give you credit.
Yeah.
Oh yeah, please do. That's the only reason I'm telling you. So you know, now that's in any cross. If it's dihybrid, trihybrid, quadruple hybrid, it's going to be that. If you have to get an F2. If the F2 is not there, the rules change. It doesn't have to be that way. It doesn't have to be. And I'm only telling you this for 2 reasons. It's because the genotype for this F2 is 1 to 2 to 1. It's always going to be 1 to 2 to 1. But you've got to know, can it be completely dominance, partial dominance, or co-dominance? You follow? And that means you got to read in the problem to see what the results are. You may even have to go to this to see if it's a 3 to 1, 1 to 2 to 1, to see how it works. Because a 3 to 1 means 3 reds and 1 white in this, but it may be something else in another problem. Now you got to figure out how that trait is expressed. But the genotype is always going to be 1 to 2 to 1. If I cross this with this, 1 to 2 to 1. If I cross this with this, still 1 to 2 to 1. Any questions on that? So the things that you're taking away with this is how to work with blood types, because blood types have 3 alleles. IA, IB, and little I. 3 alleles. We're only talking about 2 alleles here, big R, little r. But in blood type, notice I changed the superscript. I didn't change the gene. The gene is I. If I change the gene, I use another alphabet. But all of these are monohybrid crosses. The genotype for an F1, a parent F1 and F2, the genotypic ratio is 1 to 2 to 1. You just have to know what you're dealing with to work the problem. Because this problem is 1 to 2 to 1. That problem is 1 to 2 to 1. And essentially this problem 1 to 2 to 1. I had to make it complicated by just making this cross. This was not a parent F1 and F2. But I want you to see how alleles work. Now I've got to go to something more complicated, but some of the rules are almost the same. The rules are going to be very similar. So I'll ask you first. Can you give me dihybrid ratios? Give me a dihybrid ratio.
9, 3, 3, and 1.
9, 3, 3 to 1. Is there another one? Okay, let's do this.
It's gonna be this F2 generation that you got written here, right? Where
That's
like,
one of them.
Like 2 to 1. With the ratio of the phenotype, or it's either 3 to 1 or 2 to 1.
I expect all of you know how to do a dihybrid ratio by now, right?
Yeah.
Everybody's okay with that?
It's the first problem on the homework page. Yeah, you see the F2 generation has got 630 and then the 490 white. 630 purple, 490 white.
So look at corn. You know, on an ear corn, each seed is the product of one